Example number 6. Draw the shear and moment diagrams for the beam shown in the figure. As we can see here, we have a cantilever beam with a uniformly varying load, or UVL. The first thing that we are going to do here is to compute for the reaction at the support. Since we have a fixed support here, so we have 3 reactions. One vertical, and this is the AY, and we have one horizontal, the EX, and we have, of course, the moment. If we are going to summate forces horizontal is equal to 0, taking the direction to the right as positive, we can see here that the AX is equal to 0. And if we are going to summate moment at point A, this is equal to 0, taking the clockwise direction as positive. So, kukompute muna natin yung resultant ng load natin. And this is just the area of the triangle. So we have here 1/2, the base is 9, and the height is the magnitude of the load, which is 10 kilonewton per meter. And we have here 45 kilonewton. This 45 kilonewton can be found at 1/3 from the 90-degree side, and we have 2/3 naman dito sa kabila. So meaning in here we have 1/3 of 9, so that is equal to 3, and the 2/3 of 9, and this is equal to 6. And this is the location of the resultants of our load. Okay, so first we have here the moment at A, and we assume that it is directed counterclockwise, so this is negative. Then this 45 kilonewton here will rotate clockwise, so it is positive. Multiply by the moment arm. The moment arm from the point A is 6. And this is equal to 0. So computing for the value of the moment at A, this is equal to 45 times 6, and we have here 270 kilonewton meter. So we have here 270 kilonewton meter. So since we have a positive answer, meaning the assumption that the moment at A is directed counterclockwise is correct. So meaning this is directed counterclockwise. In order for us to compute for the vertical reaction at A, so we have to summate forces vertical is equal to 0, taking the upward direction as positive. So we have here AY, assume directed upward, so it is positive, minus we have the 45 kilonewton, it is negative because it's directed downward, and this is equal to 0. So solving for the value of AY, then AY is equal to 45 kilonewton since it is positive. So the assumption that AY is directed upward is correct. Since we already computed for the value of the reactions at the support, so we can now draw the shear and moment diagram using the area method. We have here AY is equal to 45 kilonewton upward, and this moment at A here is equal to negative 270 kilonewton meter. For the shear, so the shear at point A is just equal to the reaction AY, 45 kilonewton. So we have here 45 kilonewton. The shear at B is equal to shear at A minus the area of the load diagram for the segment AB. And we have here the shear at B is equal to 45 minus the area. Of course, we already computed for the area here, that's 45. And this is equal to 0. So meaning we have 0 shear at point B. And if we are going to connect this 45 kilonewton here to 0 here, what we are going to do is to make use of the dYIX. So since we have increasing load here, we will be using the IX and increasing bend the x-axis. So in this case, if this is the origin, no, and this is our point in quadrant 4, this is the x-axis and this is the y-axis. Now, since we are going to bend the x-axis, then this is the curvature. And this is our shear diagram. How about the moment diagram? So, for the moment diagram, we have the moment at A is equal to negative 270 kilonewton meter. So we have negative 270 here. And the moment at B is equal to negative 270 plus the area of the shear diagram. No? And tatawagin ko tong area 1. So that's area 1. So we have here the moment at B is equal to negative 270 plus, bakit plus? Kasi yung shear diagram natin is positive area. So this is just area of the parabola, and that's 2/3. The base is 9, and the height is the magnitude of the shear, that's 45. So we have here moment at B is equal to negative 270 plus 2/3 multiplied by 9 and 45. And we have here 0. So the moment at B is equal to 0. So meaning nag-close na yung ating moment diagram. Now, since we have increasing, no, na shear, no, so since we have decreasing na shear from 45 to 0, no, ibig sabihin we will be using the dy. Decreasing, bend natin yung y-axis, no. So in this case, if this is the 270, ito yung next point natin is in quadrant 1, ito yung location ng x-axis and this is the y-axis. But we are going to bend the y-axis, so therefore, ito yung curvature natin. And kung titingnan natin dito, so this is our moment diagram. Now, for the degree ng curve, no? So we have here degree 1 since this is a line, and after integration n plus 1, so we have here degree 2 curve, and of course we have here degree 3 curve. And this is our shear and moment diagram for the shown beam using the area method.